Some of it was already there, and then I changed some of it, so if you can't see it, I'm going to read it off. Scientific notation is a compact way of writing very large or very small numbers in the form a times 10 to the n, where a is between 1 and 10, and n is an integer between 1 and 10, and it's positive. The absolute value is positive, yes. Yes.
This one was actually really easy. This one's like, even like the last one's kind of easy.
So this ties really well into our exponent rules, because once we get into the subtracting, adding, multiplying, dividing, which I do or don't know if you did that in middle school or not, the exponent rules are applied here. For example 1, we have the minimum distance from the Earth to Mars is approximately 284,000 miles. We want to write this number in scientific notation. Anyone know how we would do that?
What did you
do? What?
Write this in scientific notation.
2.84 x times 10 over, to the power of 3, 4, 5.
So think about the decimal being at the end, and you want this decimal to go in between the first two numbers between 1 and 10. So this would be 1, 2, 3, 4, 5.
Oh, this is like what happens for the knockout number on the calculator. They can't go like too long.
Yeah, so when numbers are way too big or way too small, and you see something like e to the or 10 to the, that's what it's doing. It's just making it more condensed, basically. Alright, and then in example 2, the 2004 Indonesian earthquake slowed the rotation of the Earth, making the length of a day, I don't know what that is decimal-wise, but a bunch of zeros, 0.268 seconds short, so really, really short. We're going to do the same thing, but backwards. How would we write this one in scientific notation?
-6 times 10 negative
10 to the
negative power 6. That's what I said.
So, if you can see it or if you know the placements and don't need to count, that's fine. If you want to do what I just did and count, my eyes trip over numbers, so I have to physically count or I lose track. Okay. Anytime you go backwards with really small numbers, you have negative numbers, but anytime you go forwards with positive numbers, positive exponent. So in this section, any of those we want to see you go over, have questions on. Moving on. If you want to remember this mnemonic to help you when adding or subtracting, if you're moving it to the left, you're going to add to the exponent. If you're moving the decimal place to the right, you're going to subtract the exponent. So you can use large. And then, in this case, if we have the same exponent, so we're going to be talking about this when we get into polynomial operations also. But if we have the same exponent, we are not doing anything with those. Those stay the same. We're just adding the two decimal places. So add those two. What do you get? Add 8.4 and 5.2. 8.6, and then this would stay the same, times 10 to the second. You could also put this in your calculator. I'll do that really quickly.
So what if it happens different?
Yes.
Say that one more time.
Like what if the exponent is not?
We're going to do an example like that.
No, you put one in the inside
Yeah, I did. Okay.
and the other one in the outside.
There we go. But it's going to give it to you in standard form. You could convert it back to scientific notation. So that would be 8.6 times 10 to the second. Or you could change the mode to scientific. And it'll give it to you in scientific notation. So you can always double check yourself in the calculator. But if we have a different exponent, in order to combine these, think about combining like terms, you have to have the same exponent. So you have to change one of them. It does not matter which one. But by changing the exponent, you change the decimal. So let's say we wanted to make this 6 instead of 7. For it to go down, we'd be subtracting. So we're going to move the decimal place to the right. Then the process would be the same. Add 95 and 1.1. But we can't leave this like this because the decimal place isn't between a digit between 1 and 10. Right now it's at 96. So we have to move it back 1. And because we moved it to the left, we're going to add 1 back to the exponent. You could have also did the other one, change that exponent to 7, then you'd have less to move back. And then again, you can always double check yourself in the calculator. Questions on that?
Can you leave it there for a second?
Did we want to see 3 or 4 before we go on to the next page?
Is it 3?
So we have to make the exponent the same. Which of these do we want to change? The first or the second? Okay, so if we're changing the first to be an exponent of -5, to get -5 we would have subtracted. So that's going to move this to the right. The 72.4. So add 72.4 and 3.18. How many you get? Wait, what?
75.58.
And then we just have to move this once more, put it in between 7 and 5. And because we moved this to the left, we're adding 1 back to the exponent. So your final answer has to be in true scientific notation. You could not leave your answer like 75.58.
Wait, how is it connected to 4?
we moved it back to the left. We moved the decimal place back to the left, so we had to add 1 to the exponent.
Wait, so wouldn't that be -6?
So adding, not subtracting. Right, on to the next page. Now we're subtracting. Same rules. If the exponents are the same, just subtract the decimals. So like in number 8, 7.59 minus 2.32 is
5 point.
and then we would just bring down the times 10 to the -2. In this case, with scientific notation, leave your negative exponents. Do not change them. But your scientific notation problems are going to be mixed in with your exponent rules, so you'll need to know the difference.
Are you never going to give us an example like -4 and +8? Because they're all like 1 from each other, the exponents.
Well, she did in question.
In question 9.
That's still 1.
I mean, on the bottom.
So in the multiplying and dividing, that's different. But in the adding and subtracting, they have to be like 1 away.
Okay.
Alright, so let's do an example where we have to change it, like number 9. Do you want to change the first or the second?
The second.
Okay. So in order to make this 12, we have to add 1, so we're going to move this to the left. And then subtract 0.93 from 5.02. I don't know what that is. In this case, you wouldn't have to change anything back. It's already in scientific notation.
Is that 22?
Which one? No, it's supposed to be 12. My one was really big for some reason.
Alright, when you say it has to be in scientific notation, you mean it has to be like between 1 and 2.
The number before the decimal place has to be a digit between 1 and 10. I can't speak today. Yes. In general, when you're changing them, if you pick the smaller one, I think that's what's been working so far. The smaller one, then you don't have to do 2 steps. You don't have to change it back. But it doesn't matter if you do either one. Or double check it in the calculator. Alright. Questions in general about adding and subtracting? Okay, on to multiplying and dividing. So we're going to actually multiply and divide the decimals. Use the product or quotient rule. So if we are multiplying like bases, we are doing what with the exponents? Adding. And if we are dividing the like bases, we're doing what with the exponents? Subtracting. So we're going to be using those rules here. So let's try number 1. Multiply 2.8 and 1.9. 5.32. And then we are multiplying like bases here, so add the exponents. So this would be 10 to the 11. So multiply the decimals, add the exponents if you're multiplying. Sometimes you'll get something where you have to fix it, like number 3. Multiply 3.4 and 8.5. 28.9. And then if we were to add the exponents, what would that be? 4. So right now this is not in real scientific notation because the decimal place is not behind a digit between 1 and 10. So if we move it to the left, this is going to become what exponent? So 2.89 times 10 to the fifth. Again, these can be double checked in Desmos, in the calculator, whatever, same thing.
You're sniffing. What day was it? Influenza.
I think I said it wrong. I was looking at the wrong one. It was 6, but it was 8.5. There we go. 2.89
Times 10 to the fifth, or if you took it off, not that. Or you could get the actual number and then convert it back, either or. Okay. Other multiplication problems, 2, 4, 5, or 6. So we want to see do go over, have questions about.
Can we do 11?
That was not one of the numbers I just said, but sure. We'll go back into that afterwards. Okay, so now onto the dividing. Similar to the multiplying, we're actually going to divide the numbers and then use our quotient rule for the exponents. So let's start with 7. So divide 3.72 by 1.2. 3.1. And then we are dividing like basis, so we're subtracting the exponents, so that would be 10 to the third.
It's a division, multiplication, subtracted. What was it called?
When you're dividing like basis, you subtract the exponents. I'm trying to remember if 11 is similar to this. Oh,
Okay, now, can you please go through this? I don't want to try.
I was trying to remember if 11 is the same as 10, but we can do 11 and then if we need to go back and do the other one.
So for 11, it's in a different format than 7, but same process. Divide 2.7 and 2.4. And then if we're subtracting our exponents, -5 minus a -6, not negative 11.
-1.
It's just going to be 1.
I'll try.
-5 minus a -6, you're adding. You can put the 1, you don't need it. If you get something where 10 is to the 0, just put 10 to the 0 in general. I'm going to go back and do 10, and then any others we want to see do go over, and then you guys will have to practice, because we're not doing anything else today. Alright, for number 10, one where you might have to change it, divide 2.1 and 2.8. And then 7 minus 3 would give us to the 4th. Because the decimal is not between 1 and 10, we have to move it to the right. So our new exponent would be, so we're moving it to the right, so we have to subtract 3 to the third.
Is that a 4?
Yeah, it should be. Any others we want to see do go over, have questions about? So you guys have a Delta Math. My brain is everywhere today. A Delta Math on this is due next Friday. You guys have 2 Delta Maths that are due today. And you have SOL A4A, 4Bs that's also due on Monday. So you have plenty of things to be working on for the remainder of class. If you feel like you would like extra exponent rule practice, there are little review books up here. Feel free to grab one.